All right. Thank you very much for making time to come to this panel. It's my great pleasure and honor, actually, to have on the panel esteemed colleagues that are world-renowned for the research in the area that we're going to be covering in this panel. So I hope that we're going to have a lively and exciting and provocative, probably, panel to make it a little bit more lively. And so what I'm going to do is, so I'm just going to introduce basically what this panel is all about, and then I will just go over about the program of this panel. So let me start by just explaining what we mean by servitizing, servitizing of IoT. So first, of course, I'm going to go very fast on this. It's just what is IoT? It's basically about Internet of Things is how we sensorize things and then connect them, and essentially then you have an Internet of Things. And they are all around us. They have been enabled by the wide use of sensors and also the fact that they're very, very cheap. So you can put any sensor or anything. Your mobile phone, has probably around 50 to 60 sensors. So sensors are everywhere. And by putting those sensors, you basically turn anything into an Internet of Things device. Okay? And of course, it's accelerating. I just gave you a case here of smart cars. So those autonomous cars, actually, as you could see, they collect a lot of information to be able to autonomously drive you wherever you want. So, and that actually necessitates a lot of processing power, storage, and the likes. So other examples of internet connected devices, you have your smart shoes, even smart color for cows. Actually, they have used that in Australia, where, as you know, we have a lot of cows in Australia. Essentially, instead of having physical fences, so those colors actually, they tell you actually you're close to what you call a virtual fence, right? So they zap them with, if they're close, they zap them with a small, they're not cruel, small dosage of electricity to, to stay away from those virtual fences. So as you could see, it's really, we're surrounded by those IoT-enabled devices. So here, really, if you think of it for a second, IoT data is going to be the new oil, right? It used to be data. Now it's IoT data because we produce so much data through those IoT devices. Now, so far, what we have is, this IoT data is readily available. So we have the infrastructure for it, and we have a lot of products out there, commercial products, to do that. Also, it's accessible, right? So, and again, we have a lot of software products to make it accessible. What is missing is really how you can digest it. So the fact that you can store it, the fact that you can access it, doesn't mean actually how you're going to use it, right? And make use of it, right? So, and that's the part that actually is missing in this chain. So the big issue here is how you transform IoT data into readily usable information. And this is, that brings me to really the core of how we can turn IoT data into something usable, and that is through the service paradigm. So the idea there, of course, is to provide a framework for IoT data to be readily transformed into services. That is how we can servitize IoT. So that's really, so let me now tell you a little bit about what I have been doing in my own research, in my own group. So we have a lab called Sensor Cloud Services Lab, where basically we, do research at the intersection of sensors, cloud, and services. Okay, and I have a large group of people, as you could see there. We, we try to publish papers. That's part of the research, and also trying to fund these researchers through research grants. So we have two main focuses in that lab. One is the Smart Campus lab, and in that we do actually I'm not going to go through all the projects that we have. One important project we have in that lab and that focus is the concept of wireless energy services, right? Where you have IoT devices that actually have spare energy. So through crowdsourcing, what we would like to be able to do is that you're here, instead of being tethered to a power point, what you want is that if a nearby IoT device has some spare energy, that you can transfer that energy wirelessly and unbeknownst to you, right? Because energy is the thing that everybody needs, right? And like in the old days where we had the Wi-Fi, so we had before the Wi-Fi, we had the Ethernet. So we had to actually have access to an Ethernet outlet to be able to use the internet. Then Wi-Fi disrupted that, right? So we want to do the same thing actually, but with energy, rather than actually using it. So we would like to be able energy as a service, right? And actually the technology to share energy is here actually. There are a lot of products out there. It hasn't matured yet, but it's only a matter of time before that technology matures and allows people to share energy wirelessly wherever they are. Typically, it's going to be within confined areas, like like for instance, this room here, right, where through short distances you can share energy. The only reason why it hasn't really happened yet is because of the health issues that may actually happen because of the fact that we have high energy waves. So, but there are a lot of research about actually how we can mitigate the health adverse issues that actually may prop up because of the fact that we are sharing energy. So and then we have the other focus of the lab is on drones, right? So we actually have a drone lab, and what you see there is the city of Sydney model, right? 3D model, because as you know, there are a lot of restrictions to operate drones outside, right? Because of again the regulations. So what we did basically, we just okay, we can do it indoors, and we have and we're focusing on drone services. So drones used for delivery services. Okay, so I'm not going to go through the whole thing. So what I'm going to do now is introduce our distinguished panelists. Let me just introduce each panelist. So the first panelist is Professor Boualem Benatallah, and Professor Boualem Benatallah is full professor of computing at Dublin City University. He just joined, actually before that he was at the University of New South Wales in Australia for over 21 years. He was also a Sancha, which is actually a prestigious name for professors at the University of Sydney based on his outstanding performance. He has published more than 300 refereed papers in areas like service computing. Of course, he has some of the seminal work, service computing, but also business process management. And of course, he has been very active in many academic associations, and also he is a fellow of the IEEE. The second guest is our dear esteemed friend and colleague, Professor Fabio Casati, and he is principal machine learning architect and engineer at ServiceNow. And many of you know that he was a full professor at the University of Trento in Italy. And of course, Fabio has a long list of key contributions, starting from workflows to service computing, and probably many of you have referenced his work. So we're very happy to have him. Also, he has authored more than 250 peer-reviewed papers. Our next panelist is Michael Sheng, and Michael is a full professor and head of school at Macquarie University in Australia. And before that, he was at the University of Adelaide in South Australia. Mike also has done a lot of research in the area of service computing and IoT, and also did some seminal work there as well. He was an ARC Future Fellow, which is a prestigious fellowship in Australia. Also, he was the Chris Wallace. He won the Chris Wallace Award for Outstanding Research Contribution 2012. And he is a member of the ACS Technical Advisory Board on IoT. Our next panelist is Professor Sharon Dustar, and he's full professor of computer science and heading the research division of distributed systems at Technical University of Vienna in Austria. He is the co-founder of Edor.com, an ad company based in the US, and also co-founder and chief scientist of Synovus.net, an Nanjing China-based R&D organization focusing on IoT and edge intelligence. He is also the founding co-editor-in-chief of ACM Transactions on Internet of Things, as well as the editor-in-chief of Computing Spring. And also, as I said, we're really honored to have Schahram here. He's, I think we would do him injustice by listing all the things that we know of, because there are many more in terms of his contribution here. And he is an elected member of Academia Europaea as well. Our next panelist is Omer Rana. Again, he's going to be joining us virtually. He is Professor of Performance Engineering at Cardiff University, and with research interest in high-performance distributed computing, data analysis mining, and multi-agent systems. He is the College Dean of International for Physical Sciences Engineering at Cardiff University. And Rana has, Omer had many contributions to the standards via the Open Grid Forum, and worked as a software developer with London-based Marshall Biotechnology Limited prior to joining Cardiff University. And he has many other contributions, and for the sake of time, I'm going to just try to be as brief as possible. So last but not least is joining us over, of course, virtually, is Professor Brahim Medjahed. And Brahim is an Associate Dean of Academic Programs and Initiatives at the Rackham Graduate School, University of Michigan, Ann Arbor. He's also Associate Dean of Undergraduate Education, Professor of Computer Information Sciences at the University of Michigan, Dearborn's College of Engineering and Computer Science. And Brahim actually is very well known for his seminal work in the area of service compositions, and I think one of his papers is one of the highest cited papers in the area of service composition. He has won several awards at the University of Michigan, one of them being the best professor at University of Michigan. So with that, I'll go to the panel questions that I had asked all the panelists to prepare slides for. And the questions are, so for the first question is, what are the opportunities for servitizing of IoT? The second question is, what specific IoT application do you have in mind? So that is, from their own perspective, and why are they the right applications? And then the last question is, what are the research challenges and outlook for the uptake of the resulting technologies? So the format is that each panelist will present their perspective answering these questions, and then please help me. I allocated 5 minutes for each one of them, and then what we will do, and we have an order so that because we have people from coming to us virtually. So the order of intervention, we start with Boualem, then Fabio, then Schahram, Michael, and then Omer and Brahim last. Then I will open the floor for questions from the audience, and after that, we will conclude the panels. All right. With that, we're going to start with the first panelist opening, basically, remarks.
Good afternoon. Good afternoon, everybody. So how to do this one?
Yeah, you can just click whenever.
Okay. So, yeah, when Athman asked me to talk about those questions about services and IoT, so I kind of structured them in, related to what I'm doing and what I have been doing. So the first thing I want to talk about is what is the current state of services, and so that it helped me to explain the second part that I'm going to talk about. So to me, service-oriented computing already offered the right computational abstraction, basically to access, control, manage, let's say, IoT services, including buildings, devices, things like that. So that's a key aspect. So it basically, the main contribution is really unlocking the connection to services, but also allowing the connection between services, and so the interaction between services. That still basically was targeting what's, let's say, the technical interaction, mainly targeting developers who will build application on top of IoT. Okay, so, and it enabled a lot of applications, a lot of very interesting applications. So I cannot say what is interesting and what is not interesting, but like, for example, if I look at it in the context of agriculture, the context of energy, the context of health, and many other driving cars, self-driving cars, and so on, they're all interesting applications of IoT. I'll just take, for example, the health domain. If you look at what we call basically digital biomarkers, for example, where these days, in addition to a traditional biomarkers that health professionals use to monitor our health, like taking blood pressure, taking blood tests and things like that, we now have all these wearables that we can wear. We have other ways to measure other important things, and it's really probably helping monitor the health of people more constantly, more regularly, and probably maybe detect some diseases earlier, things like that. If we take, for example, this Parkinson's disease, there are now ways where doctors and professionals are using, let's say, for example, IoT or some kind of IoT to, let's say, measure changes in your walking movement, changes in your eye movement, changes in other parameters. For example, they use some digital writing pens to look at certain behavior. And from that evidence, this is evidence-based medicine, they can detect early signs of Alzheimer, for example, and they can intervene and give you some habilitation, so to maybe help earlier in the process. So that's, we can all do that through this simplification of access to services and communication between them. Now, okay, so we are in the age of data, and IoT is a good example of collecting data. And then also the age of AI and how to, as Athman mentioned, how to synthesize this data, and maybe AI is a key here, and that's what I'm going to mention. So I'd see the next generation of services. We need to think of ways to leverage these AI capabilities in IoT. And one thing that I'm going to focus on is narrowing the gap between how human work and talk to each other, things like that, and IoT. Okay, so, and services in general. So what I imagine is an environment where we do not differentiate between humans and IoT. And so we have some kind of new services, let's call them digital human services, just for simplification. But all this is enabled by a middleware, which is AI. Okay, the middleware that's going to manage this is AI. So this will help us basically to, like, for example, sense and track emotion, use gestures, use voice and things like that to perform tasks. Some of them are performed by web services, some of them by web apps, some of them by IoT, things like that. So that is the objective here. So this capability is already there, and I think that AI will enable, will be, as I mentioned, the middleware of that. So we need to really think about what is this new abstraction of services, what is the notion of middleware, what is the notion of qualities and things like that. So these are things that we are trying to figure out. So here, just to give very brief high-level things, these services, they need to have certain characteristics, and I mentioned 3 of them. One is the naturalness, meaning that they need to really interact in natural way with whether you're talking with an application or Zoom or a building or your agriculture sensor, whatever, you talk with them in a very natural way, like you are talking to human. The second thing is autonomy, meaning that once they have, because they are using AI, so we need to be able to, I will come back to them, some of the challenges of the things I'm saying, but they need to be.
First slide, or second?
No, I'm still in the first slide. Just 1 second. Yeah. So the autonomy, meaning that once they are confident in their AI decision, things like that, maybe we should then take decisions. Okay, like for example, if it's autonomous, it's smart. Let's say smart car, not autonomous, smart car, meaning that maybe it will detect that something may need replacement, and it already contact the part that is needed and the shipping and things like that, and book the appointment with the garages and things like that. So that's just simple things, meaning that for this kind of things, maybe we can trust. But the challenge here, so when I trust the software to do that. And the other thing that they should be adaptive and continuous learners, meaning that they need to always act on the supervision of a human until they have certain maturity, and that's how a human learn basically. So the second slide that I have, I talk about the challenges of realizing this kind of new vision or new way of mixing digital human with traditional services. So one of the challenges that maybe sound simple, but we are working on this, and it's very like, you know, the AI that we have, it basically will help you to realize a task that talk to one sensor or the other, or one service or the other. But once tasks start to require orchestration of a number of services, things like that, it's still very hard for AI to do that. And specifically when interaction, they are conditional, meaning that they require to satisfy certain policies or certain privacy requirement or certain, like for example, I want to cook, the AI helped me to find and cook a recipe of Italian pizza or something like that, but I'm allergic to certain, I have some certain allergy, which means that I have certain constraints. So the AI should be smart enough to also suggest to me and run this. So it's still very hard to run any, and if we want AI if we want AI to work in this context of IoT, things like that, meaning that we want it to help us perform complex processes that involve hundreds and sometimes tasks, not only one task, things like that. So that is still a big challenge. The challenge is also, like, for example, if people follow like this deep learning model of language model, things like that, if we want to, we need to be able to feed them, and they need to understand what I call process knowledge, things like the policies, process models, how to chain to services, things like that. They need to be able to understand that, and that's not really the case. I think one thing that we are still already doing, but it's important, is that the AI is already helping leveraging context. For example, if you take software like Google, whatever, it knows a lot about us. The main challenges that I see that we need to tackle from the beginning is what I call quality control. Okay, so things that are still they are very important, things like privacy and security, they will just be more complex in this connected and specifically IoT that will use AI and things like that. But there are other issues that we are not even know what to do about, things like bias, things like how about if AI become too smart and it start to be selfish and start to harm us as a human. For example, it's already the case. We are all addicted to our device. I'm addicted to my email, things like that. So this how about if AI started learning my patterns and started understanding, yeah, I am addicted, so that it will give me what it wants and I will not be able to resist it. So these are the things that are subjective concepts. We don't know how to detect them. We don't know how to. So what I am pushing for here is that we need to have an engineering discipline for that, meaning that the same way we engineer for performance, security, privacy, things like that, we also need to look at safety and bias and things like that. Yeah, so that's what I wanted to say. Thank you.
Thank you, Boualem.
Good afternoon, and thank you, Athman, for the chance of being here with this great group of people. It's really a pleasure. I'm probably the least competent in this group on the IoT field. So I'm going to try to bring some perspective based on my knowledge in services and what I see in my company, the company I work for, ServiceNow. Not many people know it, but you probably use it every day, even if you probably don't know it. It's the world's largest digital workflow company. And as part of this, lots of the business we do is in domain that have a very strong IoT component. And I have the luck to be able to speak with customers almost daily, and discussion on IoT and the opportunity there are typically also some of the aspects which are discussed with them. So I try to bring some of that perspective here. I stole this quote from this definition from Servitizing, though not from ServiceNow. It's, I think, one of the most successful, if not the most successful startup in the IoT servitization space. And they paint this super exciting picture of, connected services that, as Michael said, has been there for quite some time. So one thing to keep in mind when we discuss about servitization in IoT is that many of the things we are saying today have been said for decades, right? For really dozens of years. I remember actually, many of the points discussed here, we discussed when with Boualem, we organized the first workshop on his services in Egypt. This was when the pharaohs were still there to some extent, it feels now, right? And what I think we have seen is, of course, the IoT wave brings an entirely different scale, variety, challenges based on the size and connectivity. So there are additional challenges, but many of the concepts were actually there. And I think we have seen in this last 20, 30 years how difficult the problems are. And I think sometimes as a research community, I think we also need to look at ourselves and consider whether we have been as effective as we could have been in tackling some of the challenges that servitization of things bring. Sometimes I feel that as a community, we tend to abstract and oversimplify the problems, and sometimes we leave the hard challenges behind. And I think that's something that I think going forward, we need to be, let's say, mindful of what we do. So one of the questions Athman asked is, what's exciting, what's interesting? And on the left side of this slide, I try to write what I hear our customers being excited about, right? And frankly, they are the things you can imagine, right? Optimization of processes, better customer experience, live monitoring, personalized services, and maybe the ability through the famous low-code movement for everybody or a broader say audience to be able to actually write workflows over things. So that's what excites our customers, and we try to deliver on that. What I'm personally super thrilled about are the things on the right. So as a consumer, I really look forward to seamless experiences in every aspect of my life and better management of the expectations. I'm not sure how many of you work in customer service, but when you work on support and customer service, you know that the main aspects that leads to customer satisfaction is the comparison between the quality of service that you give compared with the expectations. So the key point that every company strives for is setting the expectations right. That's really the most important aspect. So much that I've heard many companies that at first, in the first interaction with client, try to keep the quality of service a little bit lower than they could. Because if the first interaction is awesome, then the expectations are really high and your customer is going to be consistently disappointed, right? So really the expectation and setting of the expectation is the most important thing. The second thing I find really exciting is the ability to optimize and reduce waste. Not all the IoT servitization is going in this direction. Some of that increases waste. But clearly, one of the main optimizations we can do for a better plan is really to reduce the massive amount of waste we do. I know that we do a lot in my family, and that's one of the areas that is most exciting for me as a citizen. As a researcher, I look forward to researching about learning behaviors of people and through that optimizing people's journey. You can think of it a little bit closer to process mining, but process mining per se is actually a fairly trivial problem. What is hard is actually following journeys of people, learning and abstracting the interesting part of their behavior, trying to understand among the million things that we do every second, which are the processes and the goal we want to obtain and how we do this, and then abstract out how we can optimize this. This is actually something we're working on, and I think it's also connected for those of you who were following Michael's keynote this morning. He mentioned this part about search and how do you search in the Internet of Things, and we see the same problem. So some of the research I'm doing is by looking and extracting the behavior of people and the interaction of people with things, try to embed things into a vector space to find out similarities among things based on how people use them, right? And that seems to be very helpful, both when you're searching for similar services and when you're recommending the next best thing, let's say, to use. And finally, what is hard? And here I want to bring the a parallel of what I've seen in machine learning services that we deliver to customers. I think one of my main contributions to ServiceNow at least has been to shift from trying to just, quote unquote, deliver accuracy and value to deliver peace of mind. So whenever I speak with customer and I follow them on their journey towards the adoption of AI, I see that the most important thing they care about, yes, there is the cost saving, yes, there is providing better services, but all of that is second to providing peace of mind to the company and the person that decides to adopt your technology. So when they push the button and they embrace what you give to them, they want to sleep at night. So sometimes I try to convince marketing to say, hey, let's market this as technology that puts you to sleep. They don't like it that much. But the point is really, peace of mind is central, right? And I think we want the same with IoT. Yes, we want our seamless experiences in life, but I think the ability to trust the things and the infrastructure that controls the things and the company that controls the things is really paramount, right? And this has all sorts of angles. It has the security and privacy angle, it has the fairness angle, it has the humanity angle, which means trusting that the metrics we are optimizing for are in line with what leads to a better life. That is not often the case. Like even a lot of the technology we use and we do, well, I mentioned email. I think email has made our life miserable, right? And now chats maybe and real time makes it even more miserable. And the objective is not really a better quality of life, but a faster and more automated and a more efficient life, and more efficient, as maybe COVID has maybe taught us, doesn't necessarily mean a better quality of life. And once again, as a researcher, this means considering these aspects from the start, considering the fairness and the trust from the start, also considering what are the right metrics we want to optimize for. For those of you who follow my Medium post, I made obviously this point to somewhat criticize the machine learning community, because 99% of the papers are on accuracy, and when I speak to customers, nobody cares about accuracy, right? Like I said, they care about peace of mind, that you achieve peace of mind, not with accuracy, but with services that tell you when they know and tell you when they don't know. And, you know, step back and say, I don't know, I cannot help you, please ask a human to step in. And that's really what is the most important thing for people to achieve trust, right? So I think as a community, that's one of the challenges we need to focus on, is finding out the right metrics and the right way to abstract the problem so that we don't make it overly simple, and we focus on the right challenge that also matter for achieving impact in practice. Okay. And with this, I think I leave it to Sharon.
Thank you, Athman. Thank you, everybody. No, this is Michael. So
it's Michael, actually, I'm sorry.
You go, Michael.
Okay. It's really excited to see this.
If we can keep it to 5 minutes, please, because
Yeah, sure.
I want to give opportunity to these people that are itching, you know, they want to ask questions.
So definitely, I will try to finish as fast as possible. So it's really exciting to sit in this interesting panel. So I very stick in three questions Athman asked about. So for opportunities, I think we know that both IoT and service computing started around the same time, in the 1990s. So after 20 years, I think both developments are very active, very strong disciplines. To me, I think service computing is really enabling technology for IoT. So to answer the questions, what are the exciting opportunities for servitizing IoT? So there's, of course, a lot. Here I just pick up two I think is quite important. The very first one is make it easier when we have value-added services, particularly I think IoT, then we can have smart, intelligent, and personalized services. The second one I really want to mention is about the social IoT. So in the future, it's really IoT objects just behave like a human being. They have their own social network. There's lots of benefit from that. For example, they can share services, they can benefit from different capabilities. So second question, I think Athman asked about specific applications. Again, I think IoT offers so many exciting applications here. I really want to pick up aging population application. So why? I think one reason is this is still a global challenge, both for developing countries and developed countries. So every country have this aging population problem. So IoT can readily help solve the problem. So the second issue still is then there are so many challenges to solve the aging population. So indoor localization, human activity recognition, there's lots of challenges around this area. So the third question is, what are the difficult challenges around that? Again, I think there's lots of unique challenges, particularly today in my keynotes, I talk about 6. So here I just pick up a few. The very first one I think is about power supply. Okay, so battery clearly is not the solution. So you need to regularly replace battery. That is not the solution. So consider them billions IoT devices. And some applications, actually, you cannot do that, right? Just imagine sensors deployed in the remote area. So here, I think one challenge is how can we solve the problem, right? So last as long as possible, maintenance free. So for me, this is the number one challenge for IoT. So one direction, of course, is energy harvesting, right? So we can harvest the energy from various resources, then power IoT sensors. The second one, I think Fabio highlighted that is about the search, right? So how can we find the right service, IoT service, right time, right place? Don't forget the scale is much bigger. So we talk about billions of people, we talk about billions of devices. The next two, I think one I want to mention about the conversational IoT. I think Boualem touched this a little bit. So summarization also is a challenge, right? So lots of data from IoT sensors, obviously a human being cannot effectively consume. So I think there summarization as a technique come to play. So how can I generate consensus informative key imports from large data? So of course there's lots of challenges. So here I just particularly want to mention Athman, Boualem, myself, then with a small team actually identify, I think 10 challenges. So we publish in this ESM communication of the ESM. If you're interested, please have a look. So finish mine.
Thank you.
So now,
Okay, so when I think of servitizing IoT, I basically will take the systems point of view, so the distributed systems point of view. So what you see in this graph here is that we are realizing that distributed systems are really key in our society now. So if you look at the systems world, we have everything from the IoT on the left-hand side via edge, via fog to the cloud as one computing continuum. And one of the major challenges is that we live now increasingly in a fragmented world. This means that so far we are looking at IoT in only being connected to the cloud itself. Without the cloud, IoT is actually dumb. And this is one of the fundamental problems that we need to understand, that the nature of service orientation is actually being holistic, connecting all the different abstractions that you have into one bigger whole. And my proposal is that actually looking at the whole continuum from the IoT to the cloud is the best way to servitize this whole thing. Applications, there are plenty of, many people talked about it, and it's a whole fabric of different applications which only will benefit when we use servitized IoT as well. So the opportunities are actually a lot. So there are different ways to look into this. One is to look into the applications that require new requirements, have new requirements. One is location-based access from the environment. So this is what typically IoT is strong. And the second is to have compute and storage resources in the close proximity where the IoT data is being created. So this leads to, in my opinion, the biggest opportunities for servitizing intelligent IoT, namely to bring intelligence into the infrastructure itself. So far, we have spent decades, Fabio, I think, was referring to this ancient times, we have spent decades into creating service-oriented systems, creating the abstractions, etc. But it was always remaining on the application level or the service composition level, if you like. The major challenge for us in the future is to really bring the intelligence to the infrastructure itself. So two of the major building blocks for this are AI for the edge, where we actually talk about the 3 building blocks to where to establish the model building. Now everything is on the cloud. This is clearly not working forever. We have to think about how do machines learn distributed along this whole continuum. So from the edge to the fog and the cloud, and slice the data accordingly. Secondly, how to develop these algorithms. And thirdly, the whole trade-off between optimality and efficiency. So sometimes the notion of good enough, as Fabio was talking about, is also crucial. So what are the actual things that people care about? Secondly, the AI on the edge, which deals with data availability. This means that sometimes we have a lot of bias because in this continuum, devices might come and go. So the result of the servitization might be different. Second, the model selection. How do we create these models? How do we select the right models to have as the basis for decision making? And thirdly, the coordination mechanisms along all of these resources which are distributed all over the place. So in short, we have plenty of work to do with servitizing intelligent IoT, but it has to be intelligent, because if it's just IoT and we just take the data, feed it to the cloud, and the magic happens on the cloud, I don't think that this is good enough. So we need to bring in the intelligence into the infrastructure. So what we do is basically we look into one fundamental property, what we call elasticity, along a 3-dimensional space, which is resources, quality, and cost. And we look into how the applications, regardless of what is the domain, change over time. So this is the idea of the blanket, as you see here in gray, which basically spans the different configuration of resources being used, costs being put forward, and the quality of the data input and output. And this is one generic abstraction or concept, if you like, that can help us to actually create systems which are spread all over the whole distributed computing continuum and not just on the cloud. Thanks.
Thank you. Now we're going to go to
Omer.
our colleagues virtually. Omer?
Thank you very much. So can you hear me okay, guys?
Yes, we can.
Perfect. That's great. So I'll just see it. Great. I can drive my slides. So first of all, it's great to be here. It's wonderful to see the people on stage. I think these are some of the legends of service-oriented computing. It's wonderful to be part of this panel. So you can see my details there. I'll follow on from what Shahram just finished. So I'll show you this big picture. This was an animated slide, but so essentially what we have is we have a number of devices which sit at the edge of the network. So I'll take a very much an equivalent to what Shahram mentioned. So we have mobile and wearable devices. We have vehicular networks. So remember, IoT is not just IoT as wearables, but IoT can also be embedded in other systems. So we can have vehicular networks, we can have smart televisions, and so on. So as I move across the spectrum, the bandwidth requirements of these devices can change. So if I look at this picture over here, these devices have megabytes to gigabytes of data they want to ship. And these devices here have terabytes to petabytes of data with different bandwidth requirements of megabits per second to terabits per second. They consume different power, from 1 watt of power to 100 watt of power, and gigaflops to 100 teraflops in terms of the processing capability. So what we do today is we ship this data into a cloud platform. And then what happens is, right, that the processing takes place there and the results are returned back. So as Shahram mentioned, so we really are today looking at the IoT to cloud continuum, where all of this is now the cloud. The cloud is no longer a data center, but we can also do processing close to the IoT device using edge computing and with opening up of our network through software-defined network environments. we can have this concept of an internet of functions, functions that can be propagated. So the services today are essentially a combination of execution capability that is actually channeled across this whole continuum. And so we can have a whole bunch of services that we can provide now to the user at the edge. So we have edge analytics, edge caching, federated learning, what we call the embedded edge, as I mentioned, in vehicles. And also in the future, when we open up our network to from 5G to 6G communication, we will have more in-network functions that we can use to process this data in transit from the IoT device to the cloud. I guess one major change that is occurring in infrastructure is quantum clouds. So quantum computing is going to be a major change in the way we do IoT in the future. So IBM, for example, has their IBM cloud with 127 to 5 qubits. Rigetti is another very interesting company that does the same. So over the last few years, we've identified a bunch of programming environments that can help us write applications, which can then be embedded as part of this workflow. So QSharp, Qiskit from IBM, Forest, PyQuil, OpenChasm are just examples of programming environments that can help us access quantum clouds in the future. And understanding what we can do in a quantum cloud, i.e. how do we partition our applications to run on a cloud versus on an edge device, benefiting from quantum systems, I think is going to be a major challenge going forward. And I'll just mention two other quick things. So in this context, we see also the use of emergence of autonomic computing as a way to understand, for example, how do we partition our capability using autonomic self-management between edge devices and clouds. And with the availability of autonomic computing in the future, understanding how we can partition our workflows so that they benefit from quantum accelerators. So XACC is an accelerator, Orchestra, for example. In Australia, for example, there's a very interesting company called Quantum Brilliance, which I think everybody should look at. Quantum Brilliance is offering a quantum accelerator at the edge, so which is very interesting. So it's room temperature quantum computing using a very specific thing called diamond-based quantum systems. And I think combining quantum clouds with quantum at the edge opens up a very interesting new area. And I'll just finish off on, sorry, this is animated, so I don't have a ability, so this is hidden at the back. So essentially the idea is, right, so the first question we have is, how do we partition our services, right? So how do we partition our services to understand what should run where? What should run on the IoT device? What should run in the edge? What should run in the network? And what should run on the cloud? And how do we create these kind of Cartesian blanket that Shahram alluded to? But I think there's a whole bunch of stuff that we can do in the area. Of course, with the availability of edge accelerators, you can see some of these here. With AI acceleration, with NVIDIA, for example, in the future, we see quantum accelerators also available. So how do we benefit from the availability of these acceleration environments to improve the performance of our services? And how do we use these at both the edge and within the cloud? Thank you. Thank you, Athman.
Thank you, Omer. Brahim, the floor is yours.
Yep. Thank you, Athman. It's such a pleasure to be part of this panel with wonderful and esteemed colleagues and friends to provide a perspective on some of the challenges for servitizing IoT. And I would like to talk about the need and importance of servitizing IoT in real time while keeping safety as a critical requirement. And we will try to share a little bit of our experience in a research project that we have with an industry partner. Being from Michigan, it is not really a surprise that I will talk about automotive and cars. Why cars? First, if you talk to people in major car companies, whether these are CEOs, managers, or engineers, they tend nowadays to highlight their companies more as service companies. So the car industry is shifting from the traditional perception of a car as a bunch of electrical and mechanical components to a set of applications and value-added services. So unlike 20 years ago, the borders between automotive companies and software companies are blurred. The second reason or motivation is the emergence, obviously, of connected and autonomous cars, or CAV, which has been mentioned by most of the panelists. which I believe will provide new and interesting dimensions for Servitizing IoT. And this is what I'm referring this slide here as IoT on wheels. So the cab market is expected to reach $225 billion in 5 years with 17% annual growth. So if you look at the statistics, currently the average American spends more than an hour a day in their car. And this is expected to increase in the future with autonomous and connected cars, where people will be even expected to work from their cars or give presentations such as this one from their cars. So access to services on the road is really important. And there are two kinds of services that that are usually provided through connected and autonomous vehicles. The first are obviously the in-vehicle services such as pothole and black ice detection, collision detection, intersection control, map generation, infotainment, etc. But there are also other kinds of services that are provided by third parties, businesses, and other partners. Those include traffic lights, bikes, pedestrian crosswalks, smart bridges, emergency vehicles, etc. So in other words, connected and autonomous vehicle systems provide an ecosystem of IoT things and services, both in vehicles, outside vehicles, and through the cloud. And this ecosystem brings with it several challenges that you would not necessarily face in other environments. Basically, any solution to servitizing IoT in connected and autonomous vehicles has to take into account the following 4 categories of challenges. First, services in cabs have to operate in various unpredictable conditions, including roads, weather, traffic, the position and behavior of pedestrian, which is highly unpredictable, and other vehicles as well. And all these conditions may not be predicted or known in advance as we deliver and use services on the road. Second, many of the services may execute critical tasks and should be dealt with in real time to avoid damaging consequences. So being able to identify those critical tasks in real time and swiftly allocate the resources to deal with critical situations is obviously key. And for example, think about a collision detection service where even a couple of minutes to react may be catastrophic. So third, cab services are safety critical, and studies have shown that safety is the #1 delay factor for the widespread public adoption of connected and automated vehicles. And Fabio talked a little bit about the importance of making sure that users trust the systems that we are providing them with. So what is considered as a good detection accuracy level, for instance, in deep learning algorithms, may not be acceptable in self-driving and connected cars. So cab services must operate flawlessly, and any single error may be fatal. The fourth challenge listed here in this slide is scale, both in terms of IoT devices and the generated data. And Athman talked a little bit about this in his initial presentation. So statistics show that 50% of vehicles on the American roads will have connected features by 2027, which is about 400 million vehicles. And more than 29 billions of IoT devices will be available by 2030. And knowing that each self-driving and connected car will have hundreds or even thousands of sensors, and each one of those sensors and each one of those cars will currently generating about 19 terabyte of data per hour. So one of the research areas that I would like to highlight for Servitizing IoT in connected and autonomous vehicles is safety critical and real-time orchestration of cab services. And we are actually working on a project related to this with a major automotive company here in Michigan. So you would say that orchestration, composition, and mesh apps are obviously the usual suspects when it comes to research and services. But I would like to mention that autonomous cars add interesting dimensions that I believe are not as obvious in other application domains. So because of the safety critical aspect of CAV services, safety requirements should be integrated into the design, development, and integration of CAV services. It shouldn't be something that will be dealt with after the fact. So we cannot afford to experiment with and learn from our mistakes when it comes to self-driving cars, obviously. Safety has always been a concern in designing cars from the first day. There is an ISO standard called ISO 26262 that has always been used by automakers to think and preserve safety of cars. But however, this has been introduced years ago, decades ago, and it is not really CAV friendly. So there is a need to rethink about what we mean by safety in designing and providing those services, and even in building cars. So we still do not understand the full scope of what safety means in autonomous and connected vehicles. So the orchestration of CAV services should be also performed on the road dynamically to deal with real-time constraints and the several moving and unpredictable factors that occur while driving or while riding a car. There's also a need to deal with the diversity and the large volume of data generated by self-driving and connected cars. So with this, I'll conclude my presentation and give the stage back to Athman. Thank you.
Thank you, Brahim. And I would like to thank all our panelists for a very insightful set of presentations. I open the floor now for questions, and I would just ask you to be brief, right to the point, and also if you can identify the person that you want to ask the question to, and it could be all asked, to any one of them, but if you know it, please go ahead and tell me who the person or the panelist should be answering your question.
Hello, and well, thank you very much for your meaningful insights on IoT. My question is not directly generated. I just wanted your general opinion, because I do believe you give your insights assuming continuous growth of IoT. And so I wanted your opinion on the potential physical and resource limits which lie ahead of us, and how it could impact the future of IoT and, by extension, the future of servitizing IoT.
Michael? Anybody who wants to answer the question? Virtually as well?
I can jump in just to start. So I guess for us, and I think so in terms of the capability of IoT devices, I think we see, what capability or infrastructure the IoT devices have today is going to change over the future, right? So with the use of accelerated architectures and so on, I think the capability of IoT devices will change definitely in the future. And I think as Shahram pointed to, and also Michael mentioned, I think the question is that we don't see IoT as an isolated service, but it's a continuum for us that's the most significant. How do we partition services to take account of issues like security, for example, quality of service, which Param pointed to. So how does our IoT infrastructure get better, not the IoT device per se? And what capability do we offload and keep on the IoT device? And how do we decide that with the use of new versions of accelerators? That for us is a key challenge.
Okay. Thank you, Omer. Okay. Boualem, go ahead.
I just want to add to this. This is an interesting debate. I think that when we are developing this new model, things like that, we are really sometimes saying we have enough resource, we have enough energy, things like that. We are putting these problems as, but I just take an example. It's a real debate happening in the community with this foundation or language models that we can embed in IoT, things like that. And there are experiments that basically they have a lot of impact on, if you look at climate change, impact, things like that, or even impact on the gap between developing and developed countries. For example, some of the model you can only run if you have very sophisticated infrastructure, which means that if you are a poor country, you are behind in technology. So things like that. So I think it's a very interesting question to consider. Yeah.
Anybody else who wants to add? Okay. Any other question? Yes. Here, please. Oh. Why don't you, since you're close to the mic, you're going to be next.
Thank you. But my question is probably directed to Brahim. We know that with connected cars, in principle, the efficiency of traffic should improve. But at the same time, people is still, I think, very scared of this. And also, I can say that I am a bit scared of this as well. So my question is, how can we try to improve the state of the art? How can we improve the opinions people have on connecting vehicles, at least for the future, not now, but for the near future? Because we kind of need to go beyond just statistics or say it will be more efficient. We need to do something more, I think. And I would like to know what is your opinion on this. Thank you.
Brahim?
Yep. Thank you. That's a very interesting question. I think, as it was mentioned by Fabio, and so the surveys and statistics done with consumers show that trust is, or the lack of trust is the most important reason behind the delay in adopting technologies such as self-driving cars. I think including safety, security as part of the design of applications and cars is key. So it has always been the case with cars. So there were always, safety concerns. Initially, people didn't fully trust, seeing cars on the roads when you go back to the 30s and 40s. So it was a concern that consumers had seeing cars on the roads. But what helped make that relieve those fears between the population is the fact that the industry realized that early on, and then through the development of standards and also including safety as part of designing cars, they were able a little bit to relieve those fears. Although we still see accidents even with, so it's car accidents and is one of the highest reasons of death that you see in several countries. So there is still this concern even with traditional cars. But I think that including those as part of the design and coming up with the definition of what we mean by safety in autonomous and connected vehicle and is important, and working toward that. I think there's a lot of work that needs to be done to build that trust with consumers.
I just want to follow up with this, Brahim, and I think you raised a very good point there in terms of acceptance, right? So I think initially people would like to have something completely safe, right? But it never happens. It's really about being safe enough, right? We talked about this word enough a lot. It's not being totally safe, because nothing is safe 100%, even airplanes, and nothing is safe. So you have degrees of safety. So it's already that threshold where you say, now it's safe enough that I can drive it. And we haven't reached it. We know that. But we're not looking at, 100%, right? Because nothing that we know of is 100% safe.
Absolutely, Athman, I agree. And trust is not something that you build overnight. It's something that you build with time and showing progress and showing, just reaching out to the consumers and making sure that they understand what the risks are. I mean, I think we need to tell them what the risks are, as you said, Athman. I mean, even now with traditional cars, I mean, there are huge safety concerns. But there is a need to work with that. And I think that's an important challenge, I believe.
Thank you. Leila?
Thank you. Thank you, everyone, for the interesting talk. I had a question for Professor Benatallah about leveraging process management for IoT servicing. Do you think it's more promising to work on IoT-aware processes, as in consider the IoT as resources for the activities, or consider them as artifacts with their own microprocesses and them interacting, or we still need a way to leverage properly process management for IoT services?
Yeah, that's an interesting question. I think that we don't, honestly, I don't know the right answer, but I can tell you my opinions, or at least the way we are handling this. Like, let's say we look at IoT as services, okay? So, but in practice, we have processes that we need to run, okay? Even simple tasks, you can consider them as processes, things like that. In the traditional, I always compare what the way we are doing this, and the traditional way we run processes, let's say the most basic one is that we have a process knowledge, which can be as explicit as process model, or just certain rules and things like that. And we code them, and we have an engine, a middleware that follow that step by step. But here we're talking about human processes which are not structured and things like that. For example, today I want to my AI to tell me how to cook this recipe. Tomorrow I want it to tell me how to book a travel. Some of these processes, let's say they are already coded, and the AI will be smart enough to identify them and run them. But I think if we want to look at the AI as a middleware, things like that, so how can we, for example, let's say we take a model like GPT-3 or something like that. Yesterday in the hotel with Fabio, we're testing GPT-3 if we can do this kind of thing. So, like for example, okay, if you tell GPT-3, yeah, I might want to know the weather or something like that, because it's a specific task, it will know and generate the answer. If it's a task that requires extracting something from Wikipedia, it probably get it. We were saying, who is Athman Bouguettaya? And it told us who you are. So, and things like that. So, but when you are, I mean, that in general, for example, I give you one example of process, which is insurance policy. When I went to Ireland, I needed to buy insurance policy. So when I was calling people, basically, from what I understand, they were really reading a flow chart. They were reading a process, asking me, when did you arrive? Okay, based on that, they moved to another thing. So I think this knowledge, we need it into this knowledge will be in, the AI should learn this knowledge. Otherwise, it will not, it will either try to generate the whole answer straight away, which doesn't make sense, because if you have a graph of 100 nodes and question, so we need some kind of interactive AI that will ask a human the right question, but based on the answer also move on and so on. But yeah, it's a very difficult thing to do.
I want to ask a question that's a bit different. I mean, I think underlying to all the discussions that we've had so far is that IoT is good for us, right? That we're not putting into question the fact that IoT may not be good for us. Let me give you an example. If you work in smart aging, you quickly realize that smart wearables are unacceptable for the elderly. And it doesn't matter how educated they are. You just hate having this iWatch on their wrist to monitor them. They will wear it for a day or two, and then they will throw it away. And it doesn't matter how much time you spend with them, telling them how good it is for them, because we can monitor. They would actually throw it away. This actually research has been done that actually a section of the population will be resisting, right, using IoT devices to actually improve their health, to monitor them. So I think we have to be careful not to say that whatever, I mean, we may have nice tools and actually for the right reasons, but for the wrong people. right? In this case here, so we have a project actually with a company, and they told us they work with nursing homes, and they said, forget about active monitoring. Everything has to be passive, because the moment we tell them you have to have, this necklace that is smart and this, they would not do it. It's just everything has to be passive, invisible, right? So I guess, and it could be that it's not only the elderly. It could be in certain other areas. We may actually have challenges just trying to find the right framework for. What do you think? I mean, I'm just giving an example here of what I know.
Yeah, clearly, I think, of course, this is just the people against use high technologies, right, to help them. But I think for aging population, it's really, for example, you have dementia, then you forget things, then so this actually creates the situation then wearable perhaps doesn't work, so that from my experience then. So really, I totally agree. I think it need to be passive, invisible. Somehow we call the device free. So that means older people just live as normal. They don't have to remember to wear something in order to for example, prevent falls, those kind of accidents.
So therefore,
I
the
agree.
servitization
Yeah,
actually
that's right,
basically has to be also about invisibility, right? It can't be, I want to serve you, but you want to see it, right? So, you talk about explainable AI and everything, and say the explainable AI is about actually divulging what's out inside. In this case here, you actually want to hide what's inside, right? You don't want to tell people I'm monitoring you, although you are for their own, good. But because the moment you tell them you're going to have to wear this and that, they throw it away. This is solid research on aging, right? People working in gerontology, they will tell you when we reach a certain age, we start actually being very resistant to technology, and it actually has no correlation to your level of education, right? So what that means is that we have to be a little bit more creative on how we servitize, basically, IoT.
If I can just add one thing. So I've been working in the technology for the aging for a while, and I think what I saw is that you get all these 20 years old people developing for 80 years old,
Yes.
and it's really hard to know what are the needs of the people in a different age group, and there is a tendency to believe that the priority of people is survival, but that is really not the case, right? It's really is to have a happy life is more important than to be safe, and this we've seen. I think we had one success with the sensors when we made it fancy and we partnered with a fashion designer, and then it was a fancy sensor. Then you could brag about it, right? It's like you have a Louis Vuitton watch or whatever. Then it's
expensive one.
Expensive, right? Yeah.
Athman?
Yeah, sure. Go ahead. Yeah.
Yeah, just following up on that, there is a question on the chat that you may not see. So that looks really interesting that I would like to share here from Malik Muhammad. Malik said that one of the panelists shed some light on IoT applications in the health sector. And the question is, what do you see as the role of IoT in the mental health area, specifically today and in coming years? So I thought it's really relevant to the discussion that we had, and thought I would share this question with the group here.
Okay, great. Elisa?
The elder people do not accept this. I wouldn't be so worried because with all the progresses in nanotechnologies, I work a lot with people in nano now at Purdue. They're inventing things which are invisible, like smart clothing. And even in the future, glasses may capture everything. So to be honest, today still, those devices are more, intrusive, but in the future, they will be really invisible. So I wouldn't be worried, and there will be a lot of ways to capture many things. So that personally, I don't see as a problem. Plus the other consideration, the younger generation will be used. Of course, if you look at those in device, and actually there are a lot of industry, a lot of companies really developing very fancy things. Okay.
May I wanted to say something about the chat question. I think that the interesting effect that we see now is that the more technology we have, the more AI we have, the more we learn, or we have the chance to learn about what it means to be human. This is kind of an interesting effect that probably many people are not having on their radar. What I mean is, for example, I have this IoT ring, which is called Aura Ring, which basically tracks the sleep, tracks the activity, the heart rate variability, temperature, all sorts of stuff. And it gives you recommendations. And with this, I have the chance to track exactly the impact of certain actions I take in real life. So when I eat something, I can see what is the effect on my sleep and things like this. And I think that if people have the chance, some people, but not all people, I agree, but some people who are interested in it, they can use technology to improve their lives, clearly. And those people who decide not to have it, it's the same. And the relationship to mental health is, of course, also a lot connected to the sleep patterns that people have. Most people are not aware how the impact of sleep is on their mental health. And also the technologies that Elisa was talking about, what is the effect of what I eat and how everything works in my system, you know, the bacteria levels, etc. All of these things can be measured, and ultimately what we learn is how to be a balanced human. And that is actually, I think, one of the big chances of IoT usage.
Yeah. Okay. Right. So it's a very quick question. So I have a question to Professor Omer Rana. Yeah. So I'm Jimin from University of Amsterdam. So you mentioned these quantum computing, quantum communication in the IoT context. Yeah, to embed in the cloud and also on the edge, these devices. So my question here is, can you comment on what are the killing, use cases which we definitely need those quantum technologies? And if possible, can you also give some examples where we should not, or maybe we should never even try quantum technology there? Yeah, thanks.
Yeah, sure. So I think that quantum computing is really good when you have things like large parameter search. So large parameter search is a very interesting scenario where you want to search through a whole parameter space in parallel, for example, or concurrently. That's where quantum computing is good. So Shor's algorithm, which is factorization, for example, when you do n parameter factorization, that's also very, very good for quantum computing. You're absolutely right. Current quantum systems are not good for everything. There's a certain class of problems for which quantum computing works very well. I think the key challenge is how to take classical computing, which can create what we call an initial state on which a quantum computing can then optimize. So for example, many of the algorithms like Shor's algorithm, Grover's algorithm, for example, is another scenario where you create an initial state through a classical system and then pass this to a quantum computer where you can then do exploration much quicker than what you could do on a classical computer. So where quantum systems are not so good at currently are large data. So they're not so good at handling data. So big data is not so good for quantum systems right now, but trying to explore a parameter space, very much like the Cartesian black kit that Shahram alluded to. If you have a high dimensional parameter space and you want to search through that, then quantum systems are great. I think understanding how we take large data sets, transform them into a kind of a sequence of states that can then be mapped into quantum systems, I think offers a very, very interesting challenge. And I think would be a very interesting research challenge going forward. I just wanted to touch one quickly before Athman, that the IoT and mental health, if I may, very quickly. I think we talk about IoT helping mental health, but I also see children being affected by the use of IoT. If the IoT device is not there, we can have, especially during COVID-19, where people are really having real mental health problems connected to technology. And I think we should also take that into account, that if you assume that IoT devices are not always there, when they're not, right, that opens up a whole set of mental health challenges, which we should also consider. Thank you. Thanks.
Thank you very much. With that, I would like to conclude this session. And on your behalf, on behalf of the conference, I would like to warmly thank our panelists. It's been very informative, and we look forward to have similar panels in the future. Again, thank you. All right.